Right then, hello grade 9. This is the first of your podcasts and it's to do with equations with absolute value for the current algebra unit. And we're going to start just with a very quick reminder of what absolute value is. We covered it in unit 1. It's the absolute value of any real number x written line x line is the distance on a number line between its location and the origin. Thus, the absolute value of 4 is just 4. And the absolute value of minus 4 is also 4 because we ignore the sign. And the reason we ignore the sign is because of that definition there. We have to think of a number line. Oh, maybe not quite as wonky. There's 4, there's minus 4. And both of them are 4 units away from the origin. So they both have an absolute value of 4. Okay. Now, just before we consider some questions, we're going to think what happens, we're going to ask ourselves what happens when we have an inequality to do with using absolute value. So, for example, this, if we've got that the absolute value of x is less than 7, what does that look like? Well, I'm going to put my number line there. There's 0. I'm looking for numbers that are less than 7 units away from the origin. So, here's 7. Anything in this gap will be less than 7 units away from the origin. But I can also think of the other side. Anything in this gap will be less than 7 units away from the origin. So in effect, anything in this range between minus 7 and 7, not including, that's why we don't shade them, will have an absolute value of less than 7. Now, what if the inequality sign was the other way around? Again, let's think of our number line. There's 0, there's 7, there's minus 7. So we're looking for numbers that are more than 7 units away from 0. And hopefully you can see that anything bigger than 7 will be more than 7 units away from 0. And anything less than minus 7 will also be at a distance bigger than 7 from the origin. Now let's just test it with some numbers. I'm going to pick a number in this range. So 9, for example. The absolute value of 9 is 9. And 9, is 9. And 9 is actually bigger than 7. So that does fulfill the inequality. Let's try something in this range now. So maybe minus 3. Minus 3, the absolute value of minus 3 is 3. That doesn't satisfy the inequality, so it shouldn't be in the solution. Whereas over here, if I try minus 9, the absolute value of minus 9 is 9, which is greater than 7. So again, that does satisfy my inequality. Okay, so make sure you've got those things really, really clear, that if it's less than, you end up with something like this, because it's anything within that region will be less than 7 units away, whereas if you've got a greater than sign, then it will be outside the 2 boundaries. Okay, right, let's try some questions. So, x minus 11 is equal to 7. Draw your number line. There's 0. So, 7 and minus 7 are both 7 units away from 7. So both of those are what could be inside the absolute value sign. So the original value could have been 7, in which case if I add 11 to both sides, x equals 18. Or the original value, before it was absolutized, that's not quite a word, the original value could have been minus 7. If I add 11 to both sides, I end up with 4. Now let's just check. Quick check. So mod of, if I replace the x with an 18, mod of 18 minus 11, sorry, absolute value, it's just another word, mod, but I will stick to absolute value. Absolute value of 18 minus 11 is the same as absolute value of 7, which is 7, which is what I wanted, so that is correct. And if I check this one, absolute value of 4 minus 11. That's the absolute value of minus 7, which is also 7, so that is correct. Okay, 1 down, 3 to go. Number 2. We're looking at our number line. Now, we're going to ignore for a minute what's inside the absolute value sign and just concentrate on the fact that the absolute value has to be less than 20. There's our 0. 20 is here, minus 20 is here. So we're looking at numbers that are less than 20 units away from 0. So hopefully you can see that it's going to be anything in this range. Now that is not the solution because we need to consider the x plus 9. But in effect, we want x plus 9 to be between 20 and minus 20. Subtract 9 from all sections. This little step is optional. You can do that in your head. It gives us minus 29 less than x less than 11. So our solution is x has to be between minus 29 and 11. Now they may ask you to do that as a number line. Minus 29 and 11, and it would be anything. That would be our solution. Okay, right, next one. This time we want the bit inside to be greater than or equal to 15. So there's 0. Probably most of you can anticipate that we're going to use 15 and minus 15. So we want the thing in there to be at a greater distance than 15 from the origin. So we want it to be further away than 15 that way. Sorry, shaded in because it's greater than or equal to. Or further than 15 that way from the origin. Okay, so let's take the positive case first. It could be that 3x is greater than or equal to 15, in which case divide both sides by 3, x is greater than 5, or it could be that the original number was actually less than or equal to minus 15. Again, divide both sides by 3 gives us minus 5. So we end up with 0 and 5 and minus 5, and we're saying that anything above 5 or below minus 5 will make it true. And let's just do a quick check. So if I take 6, mod of 3 times 6 is mod of 18, which is 18, and that's greater than or equal to minus 15, so it is right. And over here, if we take minus 6, absolute value of 3 times negative 6 is the same as absolute value of minus 18, which is 18. Again, that is correct. Okie dokie. Right, last one. This time we've got 0 and 23 and minus 23. So we want our solution to be less than or equal to 23, so it's somewhere within this range. So we want 4x, x minus 1 to be between 23 and minus 23. And once again, we add 1 to everything, so add 1 to that gives us minus 22, add 1 to that gives us 4x, add 1 to that gives us 24. And then we're going to divide everything by 4, so half and half again, so 11, 5.5 or 5.5, less than or equal to x, less than or equal to 6. And there's our solution. And depending on how the question was set, you'd give your answer like this, or you might draw a number line, or you might suggest which values, which integer values of that would be true. So that would be minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. Any of those would make it true, but we'll look at those in class. Right, now this hasn't printed very well from Equation Editor, but if you could have a go at these 3 questions, press pause and when you're ready to have a look at the answers, press play again. Right, so let's go for some answers. The first question was x minus 2. I'm not going to go through them in detail, but just to give you the idea. So the original number could have been positive, in which case x is equal to 10, or the original number could have been negative, in which case if we add 2 to both sides, it gives us x is minus 6. So that's the answer to the first one. The second one, we want 4x to be equal to 40, so the original number could have been 40, which gives us x is 10, or the original number could have been minus 40, which gives us negative 10, and both of those would make that equation true. Finally, I'm just going to separate that out so it doesn't get confusing. We've got 5x minus 3 is greater than, absolute value of that is greater than 27. So we want things that are more than 27 units away from the origin. I need to draw this every time. If you can do it without it, that's fine. So anything above there or anything below there. So let's deal with the positive ones first. So 5x minus 3 greater than 27, which means 5x is greater than 30, x is greater than 6, or 5x minus 3 is less than minus 27, which means 5x is less than minus 24, because we're adding 3 to both sides, which means x is less than 24 divided by 5, which is 4.8. Okay, right, so I hope that's all fairly clear, and we'll have a practice tomorrow.